Linear regression is a statistical method used to model the relationship between a dependent variable and one or more independent variables. It assumes that there is a linear relationship between the independent variables, also called predictor variables, and the dependent variable, also called the response variable. There are several methods to estimate the parameters, coefficients, of a linear regression model. Some of the most common methods include ordinary least squares, OLS. This is the most widely used method for estimating the parameters of a linear regression model. In OLS, the parameters are estimated by minimizing the sum of squared differences between the observed and predicted values of the dependent variable. This method provides unbiased estimators if the assumptions of the linear regression model are met. Gradient descent. Gradient descent is an optimization algorithm used to minimize the error function, for example, the sum of squared errors, by iteratively adjusting the parameters of the model. It starts with initial parameter values and updates them in the direction that reduces the error until convergence is reached. Gradient descent can be used for linear regression when the dataset is too large for OLS or when the cost function is non-convex. Analytical methods. Some linear regression models have closed-form solutions that allow for direct computation of the parameter estimates. For example, in simple linear regression with one independent variable, the coefficients can be calculated analytically using formulas. However, such analytical solutions may not be feasible for more complex regression models. Matrix inversion. Linear regression can also be solved using matrix algebra. The parameter estimates can be obtained by solving the normal equations, which involve matrix operations such as matrix multiplication and inversion. This method is commonly used in statistical software packages for estimating linear regression models. Iterative methods. Iterative methods, such as the Gauss-Newton algorithm or the iteratively reweighted least squares (IRLS) algorithm, are used when dealing with nonlinear regression models or when the assumptions of linear regression are violated. These methods iteratively update the parameter estimates until convergence is achieved. Regularization techniques. Regularization methods such as ridge regression, L2 regularization, and lasso regression, L1 regularization, are used to prevent overfitting and improve the generalization of linear regression models. These methods add a penalty term to the cost function, which encourages simpler models by shrinking the coefficients towards zero. These are some of the main methods used to estimate the parameters of linear regression models. The choice of method depends on factors such as the size of the dataset, computational resources, model complexity, and specific requirements of the analysis. Linear regression is widely used in various fields, such as economics, finance, biology, engineering, and social sciences, for modeling and predicting continuous outcomes. However, it's important to note that linear regression makes several assumptions, including linearity, independence of errors, constant variance of errors, and normally distributed errors. Violations of these assumptions can affect the accuracy and reliability of the model's predictions.